Saxon Algebra 2, lesson 52. You guys, we're going to talk about a very cool kind of word problem called chemical mixture problems. Chemixture. That's the new hybrid I devised as a title for this. I'm not going to use it though. Chemical mixture problems type A. This is a hint. Yes, there is a type B. We'll get to that later. But for right now, I want you to fancy yourself as a chemist, and most specifically a pharmacist. You're a dude who works in a weird little pharmacy shop, not like Walgreens. We're cool chemists that have like labs that we're working in, and we are mixing together, and this is an important part of the problems, we're mixing together different strengths of the same chemical to try to create a custom percentage. All right, I'll show you what I mean. And you're going to draw these pictures exactly as I show you. Here's a container. It's a beaker because I love beakers. And in this, we have a mixture, a liquid, that is 10% iodine. Now, what is iodine and what does it do? We don't care. We just know it's 10%. All right? And then we have another mixture, another beaker of iodine, but this is stronger. This is a 50% concentration of iodine, okay? Now, in typical Goldilocks fashion, this one's too weak and this one's too strong, because what we're looking for, and notice that I'm drawing that in a slightly different shaped vessel, what we want is 20% iodine. Oh Lord, why is life so complicated, right? So you can see that what we have to do is we have to mix these two in the proper proportion so that we get this amount, and we're also told that we want to get 100 milliliters of this 20%. That's our goal, all right? So in order to work these problems, we're going to play a little game. We're going to say that we're going to take some out of this amount and we're going to pour it into this ending pan. And then we're going to take some of this and we're going to dump it in. Now, those are two different words that mean the same thing, right? We're just going to add some of both. But by using P and D, it creates variables that allows us to set up the problem more simply. So we're going to use this idea that the first container is P for pour, and the second container is D for dump, all right? So what we want to do is say that we're going to write two equations, right? It's going to be a system of equations. The amount that we pour in plus the amount that we dump in has to add up to 100 milliliters, okay? So this is in the style of our old system of equation problems. This is what we would call our quantity statement, right? The amount that we pour plus the amount that we dump equals 100 milliliters. Now we're going to write a value statement, and just like we did with our other value statements in system of equations, we're going to use these percentages to fine-tune these amounts, and that will help us take into account the strength of them. So 10% is 0.10 times the amount that we pour in plus, right, instead of 50%, I'm writing 0.5 of the amount that we dump in will equal, if we do it right, 20% of the 100. Okay, so I'm just using these percentages against this original equation, and that will create the system that we can solve. Oh my gosh, I'm so excited. Are you? This is the hard part. Doing the numbers is easy, all right? This is the hard part, is understanding how to set this up. There's a second problem in this lesson, so we'll go through this all again. Before we go any further, I don't like the decimals, and so I'm going to multiply every term in this equation by 1 so I can get rid of those decimals. So it's going to be 1p plus 5d equals, this will be 2 times 100 or 200. And then these words are not part of the problem. That's just my equations, all right? So how am I gonna solve this? Well, one thing I notice is that this has got a plain P in it and this is a plain P as well. So if I rearrange this one and write it as P equals 100 minus D, I can put that in right here. So I'm gonna write 100 minus D plus 5D equals 200. I'm just playing with algebra here, right? I just decided to use substitution because I could see how easy that would work. And so I rearranged that top equation and then plugged it in here. All right, now I have 100 plus 4D equals 200. I'm gonna subtract 100 from both sides. I'm running out of room, so I'm gonna get creative. That will take me over here, and I will have 4D equals 100, right? And then I'll divide both sides by 4. So the amount that I dump in will be 25 milliliters. Okay. And then the 2 have to add up to 100, right? Because it's 100 milliliters. So the amount that I pour in will be 75 milliliters. And that's the right answer. Okay? So I hope what you saw is that this part is very familiar, this solving of the system of equations. That's nothing new. What's interesting is this new part where we draw the picture and figure out how we are going to set up the equations and go from there. We have one more of this type A shenanigans. Okay, a chemist has one solution that is 10% salt and 90% water, and another solution that is only 2% salt. Okay? These containers should have straight edges. And then the one that we combine them in should be like a pie plate. That just helps you keep it really straight and clear in your head. Now, I don't want to say that yet. Never mind. I'll come back to what I was going to say. And here's what we're combining. We need to take some of this and pour it in. And we need to take some of this and dump it in. And in the end, we want, it says how many milliliters of each should the chemist use to make 1,400 milliliters of a solution that is 6% salt. Okay, so there we have it. 10%, 2%, we want 6%. We'll pour some of that and we'll dump some of that and we'll figure it out and we'll end up with that much quantity of this. All right, so we set up the two equations. The first one is the quantity equation. That one's always super straightforward. Pouring plus dumping equals 1,400. That's the quantity. And now we multiply by the percents, just like we did for money. It will be 0.10 times the amount poured plus 0.02 times the amount dumped equals 0.06 times the total. Okay? Being very careful to convert these to decimals accurately. All right, we're gonna have to do 2 jumps to fix these decimals. So then we'll have 10p plus 2d equals, this will be 6 times 1,400, so let's just multiply that now. It'll be 8,400. Okay, cool. Now, how are we gonna solve this? Let's solve this one for D. Let's substitute again. We'll say, from here, we'll say D equals 1,400 minus P. We'll put that in here. 10P plus 2 times this equals that big number. We'll distribute. Now, I'm in a 2 birds with 1 stone kind of a mood. Let's get rid of this. At the same time, we combine those like terms. So we'll have 8P equals, and now let's see, what about this? We have to borrow, that becomes a 6. Okay, I'm liking the division. And the amount that we poured is 700 milliliters. Of the 10%, it had to add up to this. So if I subtract 700 from that, I'll say the amount that we dumped is 700 milliliters. Now that catches my attention because I notice it's equal amounts. So I go back and look. Does it make sense that those would be equal amounts? 10% and 2%. All right, well, 6% is exactly halfway in between, isn't it? It's 4% less than that and 4% more than that. So it makes sense that we would have exactly equal amounts. So that's logical. Beautiful. Now, here's something I'm going to tell you that may blow your mind a little bit, and if so, I apologize. Because we don't need to start 2021 out with blowing our minds, but it's kind of fun. We said that these are liquids with this concentration of salt in them. What we're assuming is that this liquid that we're adding is equal to salt and water. In some of the other examples, it might be a different element, but there's something neutral that we're adding with our more interesting element that are in these combinations. Now, if we want to, we can focus the problem to be about the water rather than about the salt. How would we do that? Let me show you. In my nifty little side notebook. Okay, if we wanted to rewrite this diagram and focus on the water instead of the salt, we would say that this first liquid would be 90% water. I'll just use W for water. And this other container is 2% salt, so that would be 98% water. And we're pouring and we're dumping into the bigger container. And in this one, we're trying to get 94% water. Okay? We could set up the equations just the way that we did, and we would use these as the percents. We would write the very same equations. Here, I'll write them. This is the pouring, and this is the dumping, right? No, I forgot my watermark there. So we would say pouring plus dumping equals 1,400. That is exactly the same as last time, right? But this time, instead of using these percents, we would use these. We would write 0.90 of the amount poured plus 0.98 of the amount dumped will equal, I have to use another line, 0.94 of the total. This would be our new system of equations rather than this. Now, let me just ask you, when we can see these numbers side by side, would you rather work equations that have these numbers in them or these? That's an easy call for me. Give me 10, 2, and 6 over 90, 98, and 94. I don't want to make it hard with those creepy numbers. So All of these problems will fit this model. There are actually two components to whatever these mixtures are, these liquids, and we can focus on either one as long as we're consistent, right? We can't mix salt percentages and water percentages and expect it to come out right. But we can focus on salt or we can focus on water. Either way will work. I prefer to use the simpler percentages. Okay, but I want you to understand that. I also want you to know that salt and water, I should write this on another page, is called brine. Okay, that's just general information. So if John starts talking in a problem about brine, you know it's just salt and water. And the other thing I want you to know is with other chemicals, they sometimes use a neutral component called glucose. Is that right? Let me just look. It must be in some future problems. I'm pretty sure this is it. Glucose is a sugar-based, but it's a neutral, okay? So it'll always be something else combined with that. All right, so you can focus on either one, just make sure you're consistent. I recommend you choose the easier percentages. These are really hard problems, you guys. They blow a lot of students' minds. Focus on understanding the pictures. The solving is not difficult. Ask me questions when we chat. Thank you. Goodbye, smart people.